It's number 11 in chapter 17. It's going over the answers to that problem here. Now you should have found that in all of these problems there were mixtures of binomials and geometric within the same question, depending on whether it's A, B, C, or D. So there should have been a mixture of both within each of these questions. Number 11, we're given that 4% of people have type AB blood. Okay. It says, on average, how many donors must be checked to find someone with type AB blood? Now, it says on average. That is a big clue. On average means the mean of a particular situation. Okay? So, we either can find, we have to decide whether it's a binomial or a geometric and then use the appropriate formula. Okay? So, let's just review. What's the mean of a binomial? N times P, right? Okay. What is the mean of a geometric? 1 divided by P. Okay, so we know the different formulas. Remember that your binomial formula is on your formula sheet. You are allowed to use your formula sheet on the quiz if you want, but the geometric formula is not there. So let's decide in part A whether it is binomial or geometric, and I think that's kind of the trick to this, is deciding which one it is in each of those cases. So in number 11 it says on average, so we know we're doing mean. How many donors must be checked to find someone with type AB blood? Is it a binomial or a geometric situation? It is geometric because how long until we find our first success, right? It's a wait time situation. So that's going to be 1 divided by P or 1 divided by 0.04, which is, according to the book, 25 people. I mean, that makes sense, right? So, any questions on that? Okay. Part B says, what's the probability that there is a type AB donor among the first 5 people checked? Now, that's going to be, it could be the first person, second person, third person, fourth person, or fifth person. Okay. And we can use a slot diagram. We can use a geometric situation. There's lots of different ways to go about doing this particular problem. I'm not going to require that you use one versus another. So you guys tell me which way you did it. Anybody use slot diagrams? Okay. Anybody use geometric CDF? That's how I probably would have done it. So let's do it that way, because it is cumulative, because it could be the first or the second or the third or the third or the fourth or is it the fifth, first 5? First 5 people, right? So if we did that and you go to your calculator and you look at the geometric situation, remember, how do I find that distribution, by the way? I'm sorry? Second bars, which is your distributions. And if we go find our geometric, way down at the bottom, and we are talking about 4 or a fifth, fourth, it's the CDF because it's cumulative, correct? And so we're going to go ahead and our 0.04, there we go. And then we have first 5 people, correct? All right, so we should have gotten 0.1846. Hopefully that's what the book got, and they did. So that's just all I did there. Now, if we were talking about using formulas, okay, and then we looked at the formulas or the slot diagrams, we could say that it could be the first person, or it could be the second person, or the third person, or the fourth person, or whatever. We could go on forever, or not forever. We have 1, 2, 3, 4, and 5. So we could have said it this way. We could have said, okay, it's the first person, right? Or it could be not the first person, but it could be the second person. You with me so far? It could be the third person, which means it's not the first 2, but it's the third. Understanding what I'm doing here? And we could continue the same pattern. It's not the first 3, but it's the fourth. It's not the first 4, but it's the 5th. Okay? We could have done that. We should have gotten the same answer either way. All right? Any questions about that? I happen to think the calculator is a little easier. That's just my opinion. Okay, part C says, what's the probability that the first type AB donor will be found among the first 6 people? Well, what's the only thing we have to do differently here? Just change this to a 6. Or if we're doing the formula, We would just have to add one more situation here, which means it's not amongst the first 5, but it is amongst the 6, right? And so if we do that, let's see what the difference would be here. And I got 0.2172. And this one, I think, is 0.18. Hopefully that's the book got. They did. All right, and then part D says, what's the probability that we won't find type AB donor before the 10th person? Okay, so no AB donor before the 10th person means that the first 9 people, so if we wanted to do it this way, wouldn't that be a geomet PDF? It's exactly on the 10th person. Not cumulative anymore, right? It's not saying before, it's just saying that will happen. So you could have said geomet PDF if you were looking at that, and it would be 0.0410, right? The 10th person is where we found our first success. Do we understand the difference between CDF and PDF? Brenda? This is an exact situation as well. If you read the difference between C and D, it says among the first 6 people. So that's why among is your key word there. Whereas in part D, it says that's it, the 10th person. Okay, so that's your key word there. Okay? Yes. Yes. Binomial, but PDF is an exact situation and CDF is a cumulative. Remember that it only does less than though. Okay? Yes, ma'am. Okay, so hang on, let's just make sure that I did it right before the first person checked. Oh. All right, so let me just so that's what I would have done, and and this is, I guess, the wording of the question, and I'm not going to try to trick you, just so you know. You have a question? Yes, that's what they're asking you to do. But let me tell you why. So it says, this one is a bit tricky because it says there's no implication we actually find a donor on the 10th trial. All right, well, okay. This would be if we found the donor on the 10th person. That's what this is finding. Let me reread the question and let's see what it says again. Let's see, does it say we're finding the first success on that 10th person? Let's reread it. It says, what's the probability that we won't find a type AB donor before the 10th person? So it's not saying we actually find a donor on the 10th person. I think that's tricky. I wouldn't do that to you on a quiz, okay? But what they're asking you to do in this case is just to say the first 9 people are not successful. So that means that you would just say this, and that's really what they were looking for, okay? But again, that's kind of mean, I think. This, again, what I crossed out means we found the 10th person is the first AB blood donor. What I wrote underneath it is what they were really asking, and that is that I don't know if it's the 10th, 11th, or 12th, but I know the first 9 don't work. Okay? All right, fine, fair enough. What other questions do you guys have? Stephanie? 10, is there a specific A, B, C, or D? I don't want to do them all. I don't have time. Well, can you pick? Oh, is there only one? Okay, I'm sorry. All right, 10. Oh, okay. It says for number 10, it says for computer chips described in exercise 8. So let me just go back and look at exercise 8 for a quick second. It says in 8 that computer chips, oh, actually this is going to be 10, but we're looking at 8. So it says that 2% fail pre-sale testing. So I'm just going to write that down. Okay. And it says, how many do you expect to test before finding a bad one? Well, again, is that geometric or binomial? Geometric. How long until we find a bad one, right? So what formula am I using? 1 divided by P. So 1 divided by 0.02 is 50. Question? Yes, ma'am.
Well, no, I just, for 18A, like the mean and like standard deviation distribution.
They're on the formula sheet.
Which one? Just like the letter.
All right, so if you know it's binomial and you're trying to find the mean, remember we have this as, it could be also expected value, right? It's a square root of np times 1 minus p, because q is the same thing as 1 minus p. That's the mean. And then the standard deviation, oh, hang on, did I do that backwards?
Yeah.
Sorry, that's the standard deviation. Sorry. It's right there on your formula sheet. I just don't have my formula sheet in front of me. Yeah, and then, so that's your standard deviation, and that's your mean.
And that's for phi.
Uh-huh.
Is there one for
Geometric is 1 divided by p, and it's not on the formula sheet.
and that it is not?
I will not ask for your standard deviation at that one. Yes. What you have to do is show me what you typed into the calculator, and that's fine. Any other questions? Yes, Hunter. 18b. This will be the last question. Okay. So in question 18, we're talking about arrows. So we got to find our probabilities. It says exercise 14. So it says we hit the bullseye 80% of the time. So a pretty good shot. And it says we shoot 10 arrows. So we have n equals 10, p equals 0.8. We good so far? And then at B it says what's the probability that she never misses? Okay, so that means that out of 10 shots, she makes exactly 10 shots. Would you agree with that? Okay, so is that going to be a binomial situation? It's exactly, and it's a PDF, binom PDF, if you were going to do it on the calculator. So let me show you what I would expect either by the calculator or by formula so we're clear, okay? So if you're going to use a calculator, you would simply say binom PDF 10.810, and that would give me my calculator, or that would give you the answer. If you're going to use the formula, if it asks you to use a formula, that you would obviously have to, 10 choose 10. Remember, that's not a division, but that's actually a combination. 10 choosing groups of 10. And then you have 0.8 raised to the 10 power. And then 1 minus 0.8, which happens to be 0.2, raised to the subtraction of those, which is the 0 power. Both of those should give you the same answer. And the answer was 0.107. Yes, sir. Because that's 1. Okay? All right, I want your homework. Oh, if it's in a spiral, leave it in there. I'll give it back to you. Just leave it open, make sure your name is on it, and just put it in the chair for me, guys, okay? All right, so hopefully you were looking at this question. We're going to continue our discussion of normal distributions now. And we started this last time. Just for a quick review, what did we talk last time in terms of normal? What did I say? If something's normal, what can we say about the distribution? Something about percentages. Certain percentages occur between what? All right. So go ahead, Isaiah. You had your hand up, honey. Go ahead. You were going to say what? The mean, median, mode are equal. Good. We have a unimodal and symmetric bell-shaped distribution. All right. What else can we say about a normal curve? We know a lot more than just that, folks. Raise your hand, Brenda. Okay, so the empirical rule, otherwise known as the 68, 95, 99.7 rule, talks about what? What do those percentages correspond to? Go ahead. Okay, we can use the properties of that the normal distribution is symmetric to use parts of that, I agree. But what does 68, 95, 99.7 mean, Kyle?
It's the number of standard deviations.
Away from the mean, okay? So we know that the mean is in the middle. So if we're looking at this particular situation, our mean is 50. So we're going to put 50 here. Okay, great. And then we know that 1, 2, and 3 standard deviations above the mean, and 1, 2, and 3 standard deviations below the mean, we have certain percentages that fall. So we have a standard deviation of 5, so we'll simply add 5 at each of these cases. And we'll go and we'll subtract 5 in the other direction. And we know that 99.7% of third grade boys are between 35 inches and 65 inches tall. Okay? All right, so we sketched it out. That's great. Now, we answered some questions last time given these percentages, but this one's a little bit different. It says, what percent of third grade boys is between 42 and 53? Well, 42 is here, and 53 is here, isn't it? Why is that unusual? Why is that different from what we did last class? Because I don't have exactly 55, exactly 45. I don't have the exact numbers that are listed on here. If I asked you between 45 and 55, you can give me the percentage. What would it be? 68. We know those because of that rule. But when the percentage, or when the numbers are not lined up exactly, we have to do something a little bit different. We have to do what's called standardized. Okay? So we need to figure out, I'm just going to shade because this is what really the percentage of the normal curve that we're looking for. Would you agree with that? Now, when I say standardized, and this is something that you guys should have done last year or even in Algebra 1, depending on when you took that class, you guys are kind of in the age group where they started putting this stuff in Algebra 1, so you may, if you took it early enough, you may or may not have seen it there. But a z-score, okay, this is something you absolutely should write down because this is very important, okay? A z-score is a standardized normal score, okay? So if we're asked to look at a situation like this, where the heights don't fall on my 1, 2, and 3 standard deviations, then we're going to have to standardize our values, okay? So when we standardize, we're going to use this formula. I do believe it's on your formula sheet. Double check me, but I believe it's there. Does it look exactly like this on your formula sheet? Can you guys look? It looks a little bit different probably. It's not on here. I thought it was. Yeah, it's a little bit, it's written out in words. And we'll talk more about, it's on the top right written out in words. Okay? It's the parameter minus the standard deviation of the parameter, minus the mean of the parameter divided by the standard deviation of the parameter. Do you see how it's written out in words? The reason it's written out in words is because there are other distributions like the t-distribution, chi-square. There's other things that we use, and so it won't always be a z-score. But what it is, a z-value, this is the mean, this is the standard deviation, and this is going to be the value that we're looking for. Okay, so in this case, 42 or 53. So we need to find a z-score that is associated with each of those things. When we standardize, okay, we're going to redraw the normal curve. And when we standardize, remember what I told you last time? The mean of a standard normal curve is what? 0. And then we could go, the standard deviation is going to be 1. So if we're talking about a standard normal curve, and we can take any, remember how there's an infinite number? They can be tall, skinny, short, fat, whatever. We can take any normal curve and standardize it by using this formula, any of them. And that makes them easy to compare, okay? So standard normal curve, the mean is going to be 0, and the standard deviation is going to be 1. And I think that's the default, actually, on your calculator, but we can change that, and I'll show you that eventually. When I'm asking you to answer this question, I am asking you to go ahead and, well, I'm going to try to draw it as exact as I can. You don't necessarily have to do the 1, 2, and 3 standard deviations above like I did in the blue. You just put the mean, except for we're not going to write 42. We're going to write the z-score that's associated with 42 and 53 here. Okay? So let's find those two values. So the z-score that's associated with 42 is going to be 42 minus 50 divided by 5. Make sure you understand where all those numbers came from. 50 is the what? The mean. The standard deviation is 5. And we're just finding the one that's associated with 42. What number do you get here? Negative 1.6 exactly. Now, does it make sense that it's a negative number? Because it's below 0. So it does make sense. It's a little bit more than 1 standard deviation below the mean. Well, we know that. If this is the mean, 1 standard deviation below is 45. Aren't we a little bit more than 1 below? Not quite 2. So that number makes sense to me. Let's find, so we're going to write negative 1.6 here. What's the z-score that's associated with 53? So we're going to have 53 minus 50 divided by 5, and that is 0.6. Again, a positive in this case. Does positive z-score make sense? Sure. And we're going to find this. Now, back in the olden days, we could only use tables, and there are tables in your book in the very, very back, but we are of the age where we don't have to use trig tables and log tables, and we don't have to use normal tables either. We can use the calculator. So just like we use binom and geomet, PDF and CDF, we're going to use the normal distribution as well. So we're going to find on our calculator the normal CDF. And we will actually never use normal PDF. We will always treat the normal distribution as a cumulative density function, which it is. Okay? So we're going to go to normal CDF, and it's going to ask you a series of questions. Lower bound, upper bound, mean, and standard deviation. Notice the mean and standard deviations default are 0 and 1. When you're using 0 and 1, we're going to be using z-scores like we did here. So negative 1.6 is where we'll go here. That's the lower end of the shaded region. And then the upper end would be 0.6. And then we simply paste. So we have normal CDF, negative 1.6 to 0.6, a mean and a standard deviation since we're using z-scores. And we get about 67.1%, or 0.6709. Okay? And that is the probability there. That's the percentage. That's the likelihood. Yes? It's given to you, actually. It was told to you. Okay? It's a good question. You have to be told that. You will almost always be told your mean and your standard deviation. Or I could give you a list of numbers and you have to find it. Okay? But you should, either you're given to it or it's easily found. Good question. Any questions about this? Yes. Okay. Thank you. Do you have to do the z-score? In this case, no. There will be times where you have to use the z-score to find other things. So that's why I showed it to you in this case. So I think your question is, could I just have easily, since we could put in a different mean and standard deviation into my calculator, if I typed in normal CDF and my lower bound was 42, my upper bound was 53, my mean was 50, and my standard deviation was 5, in other words, before I standardized it, would I get the same answer? And the answer is yes, you will get the same answer. You can skip the standardizing step. Try it. Plug it in. Make sure that's true. Make sure I'm not a liar. Should be exactly. But try it. Make sure. It should be exactly the same thing. So in this case, do I have to standardize? No. You can just go straight to this case. Now, on a quiz, test, or even on the normal packet that I'm asking you to work on, what are you going to have to show me, Zachary? This set that what you plugged into your calculator. Okay, show me this normal CDF, lower bound, upper bound, and etc. We will look at some examples of why the z-score is necessary to find. Okay. One of those cases is, what if I had the heights of students in Miss Mackert's class versus the heights of students maybe in Mrs. Nash's class, and we're comparing two different normal distributions? You have to normalize them in that case. Okay. So that is, make sure I said it to everybody. If you are comparing distributions, two totally different things, and they're both normal, but they're different normal distributions, you have to standardize first to be able to compare. Okay? That's one thing, that's one case where you would have to do z-scores. But this is just one case, so it's not necessary. Are there any questions before I go on? Because that's a pretty, I kind of skimmed over it fairly quickly because I think you've done it before, but I want to make sure you understand it first. Stephanie? Yes. Absolutely. Now, when I ask you to draw a sketch, and I do want you to draw a sketch on all of the problems I'm giving you on that normal packet, you're going to draw a sketch for all of them, okay? Am I going to ask you to do the 1, 2, and 3 standard deviations? I think there's one case where I tell you to do it that way. Every other one, you can go straight to just this. In every case, you have to put the mean, and then tell me what your lower bound and upper bound are, okay? Now, this case was easy because it was right between two values. It gets a little trickier, okay? What if I asked you a different question here? What if I said, what % of third grade boys are taller than 62 inches? Let me ask you a different question. What % of third grade boys are taller than 62 inches? Okay, so let's redraw. If we look at our 62, is that one of the numbers that are exactly 1, 2, and 3 standard deviations above or below? No. So we can't use our empirical rule, can we? Which would be nice if we could, but we can't here. So we know that our mean is, well, our mean is 50. I'm not even going to standardize here. I'm going to use Deja's shortcut method. We're not comparing to. I don't have to standardize. We want to have 62, and it says more than, taller than. So where am I going to shade here if I'm looking at shading a situation? Above 62. So this is what I'm going to be looking for. So if you're asked a question like this, you must draw a picture. Okay? A picture is part of the answer. So how do I answer this in terms of what do I plug into the calculator? Question first. Oh, how do you want to answer it? You plug in a very large number. Very good. Now, 100 is not probably large enough. But some number way off to the right over here, 1,000 is probably big enough. We tend to use what we call e to the 99th power. It's a shorthand notation for the calculator. I'll show you in a minute. But let's just make sure we know. Normal CDF, the lower bound in our case is going to be 62 because it's the left-hand side of our shaded region. The right-hand version is what Sammy was saying. What number, because isn't this asymptotic, doesn't it get like close and it goes far out, it goes out forever, doesn't it? So at what point is large enough? Well, we could probably pick some large number. I tend to use this calculator speak. It's called e to the 99th power. It's just 10 times 10 to the 99th power. That's what that means. I'm sorry, 1 times 10 to the 99th power. So it is, if you look at EE, it's on the comma. That's just the scientific notation the calculator uses, okay? That just means some really large number. And then we're going to put our mean and our standard deviation in this case. Tell me what that probability is. How likely is it, or what's the probability? We expect it to be tiny, don't we? We should be. So let's make sure it is. So when I say e to the 99th, I mean you push that and then you type 99. Okay? Some way number off to the right. And then you type in your mean and your standard deviation. Okay, so we didn't standardize. So we're not going to use 0 and 1. But 0.0082 is good enough for me. Maddie.
Where do you find this in 99?
It is second the comma. If you look right above, right below the sign key, you see it there? Okay, sure. And that just it helps us with some number. And you could do negative E99 as well. That's some number way off to the left. That would be that case. Okay. But again, I think if we used 1,000, it gives you probably almost exactly the same answer. Yeah, and it's exactly the same answer. But if I used 100, I bet you it wouldn't be quite, it might be a little bit, it wouldn't be exact. But it would probably be rounded to the same thing we were looking at. Okay. So, how can we tell if we're normal? Okay. Well, we're going to actually do this next class. So I'm going to skip this little part because I want to do a little activity because I want to do something with M&Ms because I think that's kind of fun. So we're going to do something different. Huh? We're going to eat them afterwards, yes. I didn't get time to get to Costco today, so I'm going to, or yes, over the weekend. So I'll do it. We'll come back to that are you normal question on Wednesday. All right? But let's look at this particular, this case. Let's look at this situation. Okay? Sometimes we start with areas, which means we start with the shaded part. We start with the probability. And we're asked to work backwards. Okay? So the probability of having heights of third grade boys is 25%. What height is associated with that number? Do you see how it's a backwards question? So sometimes you're working backwards. Okay? Now, this is a textbook situation, and we're not going to be using the Z tables today. We're going to actually be using the calculator. So let's look at an example. Okay? So 1, 2, and 3. These are our 3 questions I'm hoping to get through before I send you off on your way. Your homework is just going to be work on your normal probability packet, by the way. SAT math scores in a county were approximately normal with a mean of 420 and a standard deviation of 80. Okay? Are those good math scores, by the way? Is 420 a relatively good SAT math score? But it's an average. It's a mean, right? So you expect some people to be below it. We're AP students. We expect to be much higher. Would you agree? Okay. Well, let's see. So 20% of the students scored below what value? I'm not asking for a percent or a probability. If I'm asking for a percent or probability, I'm going to be using normal CDF, right? I'm not asking. I'm given the percent. I'm going backwards. So let's draw the picture in this case. What's the mean? Remember, when we draw a picture, the mean always goes where? In the middle. So we're going to put 420 here. 20% scored below what value? So is 20% going to be on the left-hand side, the right-hand side? So we're always going to go from the left to the right. So I'm talking about 20%. I'm trying to figure out what value this is. And I know, according to my picture, that the percentage in here is 20%. Are we okay with what my picture is? Again, this time I'm given the percentage. I don't know what number that is. All right, well, what we could do is there is a button on your calculator called the inverse normal. Okay? So I want you to find it. You use this when you're given the percentage and you want to find the value. But you have to be careful. So inverse normal is again in distributions and it's option 3. Do you see it there? Okay? And it's asking you area. That's the same thing as the percentage of the curve that's shaded. So in this case, what would it be? 0.2. Make sure that you're doing it as not a percentage, but as a decimal. So 20% is 0.2. Now, it's asking for a mean and a standard deviation. Look at what the default is. If I leave it as 0 and 1, what kind of an answer is it going to give me? A z-score. Do I want a z-score? No. What I want is the actual test score that is associated with the 20th percentile. You can think about it that way. So I'm going to put in my mean and standard deviation of 420, and the standard deviation was 80. So inverse normal, 0.2, 420, and 80. Again, is your percentage, mean, and standard deviation. And we should get 352.67. Now, I realize and you realize that your SAT scores have no decimals, right? So we would round this probably to 353, okay? So the 20th percentile math score would be 353. It's pretty low, okay? Now, how does number 2 change this? I want you to, we're running out of time, but how do I draw number 2? Same picture. What do you always have to put on your picture? The mean, so put 420 there. And what am I looking for? Where does the 95th percentile? Right, left? Definitely right. You should know that it's always to the left, just like binomials are always less than, same or normal, okay? So we are looking at this, and we would shade all of that. Okay, and how did you get that? Tell me what you typed exactly into your calculator. Tell me what you typed into the calculator. I want to see your work. Inverse norm. You don't put 0.2 at all. You just type in what? There you go. You change the 0.2 to 0.95. Good. All right, and when you did that, what'd you get? I'm sorry? Okay, and what was it exactly?
Exactly 551.588.
Okay. Good. So 551.588, which we will round to put it in context of 552. Okay. Do me a favor and show me both of those answers so I know what you started with and what you rounded to. Okay? Okay. All right, let's look at this last question. Draw the picture. Middle 50%. If we're thinking about a box and whisker plot, the middle 50% is just the numbers Q1, Q3, isn't it? Okay. We're not looking at a finite set of data like that. We're putting our mean on here. We want to know what both of these are. So this is the middle 50%. What are each of the tails? You're thinking of one standard deviation. This is different percentage. We're given the percentage of 68%. I'm sorry, 50%. Okay, it's not standard deviation. The standard deviation is 80. Each tail is what? 25. How does that help me? If this tail, are we okay with how it got to be 25? Because if the shaded region is 50, then each of the tails have to add up to be 50 also, right? So one tail is 25%. Why is that important? I have to know that. Not even yet. To find this first number, aren't I looking at 25%? Okay. So to find this first number here, I'm going to use the inverse norm of 0.25 mean and standard deviation. What am I going to use for the highest one? 0.75. Very good. You actually don't even need to, because it's just 0.75 is just that and below. So you just said between what two values. So those are the two values I'm looking for. The question said between what two. So you need to find them both. Now it might ask you what the difference is or something like that, but it doesn't here. So, all right, so 0.75, 420, and 80. And what numbers did y'all get, just out of curiosity? I got 366, right? Okay. So what would it be?
473.95.91.
So what would it be? 474? Good. Now, The biggest thing that you guys are going to struggle with, I'm telling you this ahead of time, is knowing when to use inverse norm versus knowing when to use normal CDF. Okay? So let's just review that real quick. Go back to the, well, sugar, I skipped a whole bunch of problems. Sorry about that. And look at this original problem. What were we looking for? What percent? If you're looking for the percent or the probability, both are okay to ask, I'm going to use normal CDF. If I'm given the percent, like I was down here in this case, I'm given the percent, I want to find the value that's associated. That's when you're going backwards and you're doing the inverse norm. Okay? That should help you quite a bit on your packet. So your only homework is to finish it. Bring it with you Wednesday. I might be able to answer questions and I might be able to collect it Wednesday. So I think that's probably what we'll do. So get as much of it, get, if not all of it, done before Wednesday. There might be one problem you can't do, and we can talk about it in class on Wednesday, all right? But I want you to try all of the others, and then we'll talk Wednesday about how do I tell if something is normal or not? How do I assess normality?